Hello, everyone. It's my pleasure to have this opportunity to introduce the research of my team. In recent 10 years, my research group focused on mining various big geodata to infer geospatial patterns of human behaviors. They infer the geographical environment. This is based on the background that the rapid urbanization in China and the capacity of harvesting various big geodata. So the title of my talk today is Big Geodata for Urbanized China, Method and Applications. Okay. This is the outline of my talk. First, I will introduce the urbanization process in China and the concept of big data. And then I will introduce a term coined by me and my colleagues, social sensing. And in the third and fourth part, I will introduce some method of big geodata to sensing places and sensing spatial interactions. And the fifth part will be the conclusion part. Okay. In the past 40 years, China has experienced rapid urbanization process. This curve shows the urbanization rate from 1969, about 50 years ago. And we can see the rapid urbanization procedure. Recently, maybe in 2018, the urbanization rate have surpassed 50%. Okay, the left picture shows the urban expansion of Beijing monitored using remotely sensed data. We can see the urban area have greatly expanded during the past 40 years. This is the picture in about 40 years ago, Beijing, and this is the current urban area of Beijing. The contrast is so impressive and indicated the rapid progress of Chinese urbanization process. Okay. Meanwhile, there are many megacities in China also encountered various problems. For example, traffic congestion and air pollution, and many cities and residents in different China cities have been used to such a situation, such as the haze and traffic heavy traffic and so on. Okay. To this, here I show you tragedy happened about 60 years ago. It's a well-known public secure event. On 31 December 2014, a deadly crash occurred in Shanghai. About 90 people were killed or injured. So this is also can be also viewed as a problem that many megacities to be faced. Okay, to solve these problems, in my point of view, big data provide us a promising approach to tackle such issues. With the development of information community technologies, we have entered the big data era. Such big data can be collected from mobile phones or mobile devices or sensor web or GPS-enabled vehicles. Okay, you know there are many giant internet companies in China, such as Tencent, Alibaba, and Baidu. Such companies have dominated the Chinese information technology markets. Meanwhile, they have the capacity to collect large volumes of big data. For example, using Tencent data, maybe we can collect about 100 billion points one day. Such data has spatially temporal tags, and we can easily to georeference such data to monitor to describe the spatial temporal patterns of human behavior. So it is relatively easy for Chinese scholars and government to employ different types of big data to help us to solve different urban problems. Yeah. Maybe most of you have familiar with the 4 V's properties of big data. However, regarding big geo-data, besides, sorry. Okay, sorry. Yep. Besides the 4 V's properties, big geodata have 2 additional characteristics. First, each data record has spatial temporal text. Second, each data record is associated with individuals. For example, one passenger may take taxi from the origin point to another destination. The pickup points and drop-off points are both well recorded with precise geographical coordinates and the type. Although the spatial behavior of each individual is relatively random. However, if we can harvest large volumes of individuals, there are many interesting patterns that can help us to understand the spatial structure of a region or a city. Such insights are valuable for urban management and urban planning. Such data sets include location-based soft media data, mobile phone data, text data, and metro card data, and etc. Here I show you an example of big geodata. This data set was collected from Tencent. You know, the Chinese population is very large. There are maybe 1 billion 1 billion users for Tencent. If one user generates 100 points one day, so the data volume is very large. From this data, we can clearly observe the spatial distribution of major cities of China, such as Beijing here, and Shanghai, and Guangzhou, and Chengdu, and Wuhan. Also, we can clearly observe the famous line, Huhuanying line, from this point to this point. This line divided China into two parts with closely areas. However, the population density contrast is very significant. Okay, this figure is very similar to the characteristics of night light remote sensing image. However, it is created from social media data. Okay. So such data can be well used in urban management. For example, let's revisit the Shanghai stampede tragedy. With the support of large volumes of position data, we can clearly see that during the time of when the tragedy happened, the population density is about 2.5 times of general days. So if we can collect such population dynamics information in a real-time manner, we can efficiently prevent the occurrence of such tragedy, right? So if we review different types of big geo-data, we can categorize them into three types. First, they are individual levels data, point, for example, point. More precisely, it should be a spatial temporal point with geographical coordinate and temporal text. For example, if one person posts a social media record, his or her position was recorded, as well as the time. Okay. The second one is OD flows. It records a pair of spatial temporal points, and then a trajectory. Besides the origin and destination, a trajectory also includes the media points along the trajectory. Okay, these three types can be categorized as individual level data. At the collective, we can easily obtain two types of spatial data. The first one is spatial temporal distribution of human behaviors. For example, the left figure demonstrates the activity density of one particular activities. For example, study, working, or recreation. Okay. And the second one is spatial interaction strengths. The right figure demonstrates the spatial interaction the spatial interaction volume between two TZs of Beijing. For example, from this TZ stand for traffic analysis zone. It's a unit for transportation analysis. For example, from this TZ to this TZ, there are 100 passengers. Then the spatial interaction volume will be 100. With the support of different types of big data, we can easily measure the spatial interaction stresses between any pairs of spatial units, right? Also, with the support of natural language processing and computer vision, we can easily extract information from images and texts. So such data help us to enrich the semantics of places. For example, the left part, the right part shows the word cloud of the tweets posted in Paris. We can clearly see the major topics of such tweets. Clearly, if we create the same word cloud for another city, for example, say London or Beijing, the topic will be obviously different, right? So the text and images help us to understand the semantics of different places. This is the third types of big geodata. Recently, many Chinese scholars have published a lot of paper on different types of big data, such as text data, social media data, and mobile phone data. Recently, I searched using a document database to count the number of papers focusing on different cities. Clearly, we can see Beijing has attracted much attention, most attention. Sorry, here is Beijing, and then Shanghai and Shenzhen, and also I counted the number of papers using different types of data. We can see that text data play an important role, and then social media data, and then mobile phone data. Okay. Considering that big geodata help us to analyze the spatial temporal behaviors and mining the patterns. Such patterns help us to understand the geographical environment. I use the term social sensing to describe the capacity of such big geodata. Clearly, the term social sensing is coined as an analog of remote sensing. As we all know, remote sensing help us to better understand our planet from in past maybe 70 years. However, remote sensing mainly capture the physical properties of our world. It is difficult to extract social economic properties from remote sensing data. Fortunately, social sensing or whereas big geodata help us to complement such the weakness of remote sensing. So, in my point of view, if we can integrate social sensing and remote sensing, we can better understand our world. For remote sensing, there are many sensors. However, for social sensing, each individual plays the role of sensors. This is consistent with the idea proposed by Professor Goodchild in his famous VGI paper. Each individual plays the role of a sensor, right? If an individual makes a phone call or takes a taxi or posts a social media record, he will play the role of sensors in social sensing, right? With the term of social sensing, we have the research framework of to deal with different types of big geo-data. First, we can extract human behaviors from 3 aspects. First, social ties. For example, if A makes a phone call to B, then we can see that A and B have a social tie. Second, activities and movement. Using taxi data or mobile phone data, we can easily extract the movement information of particular individuals. Third, emotion and perceptions. This can be well extracted from social media data and images. At the collective level, we can calculate the spatial interactions, land uses, and place semantics, or they together describe the patterns of our geographical environment, especially our social economic environment. So this is why I use the term social sensing for the capacity of big geodata. How to conduct research using social sensing data? In my point of view, understanding intra-urban heterogeneity is a foundation. We all know that inside one city, the physical landscape and the population are heterogeneous. For example, in different areas, the landscape are different. Also, the residents in this area are also various, right? We can use social sensing data together with conventional GIS data, such as building data, POI data, and remote sensing data. Together, we can measure the intra-urban heterogeneity from both human and physical aspects, right? Here, I will show you an example. This is a famous ant tribe village in Beijing. In Chinese, it means Yizu. There are here the environment is clearly in mass, right? And there are many young guys rent the room with a very low price. Their incomes are also very low. Okay. However, in close to this area, maybe only 1 kilometer, there are a villa area. The residents in this area are very rich. Okay. From the remotely sensed images, we can clearly compare, find the differences between these two areas. This is the villa area. The environment is clear. However, in the anti-tribe village, the environment is relatively messy, right? Like this, okay? Also, with the support of big geo-data, we can easily generate the population density of these two areas. In the left area, the population density is very high. As a contrast, in the villa area, the population density is very low. So this phenomena tells us we can integrate both physical characteristics and human characteristics to demonstrate the intra-urban heterogeneity, right? In order to represent intra-urban heterogeneity, place is a basic unit. Also, place and space are two key concepts in geographical analysis. Regarding space perspective, we pay much attention to shape, distance, and so on. On the contrary, regarding places, we emphasize on human experience, feelings, perceptions, activities associated with them. Okay. Clearly, big geo-data help us to formalize different places. First, as we all know, places are with the characteristics of vagueness. In other words, the boundary of a given place is indeterminate. For example, we all know Northern California and Southern California. The two places are both well known. However, if you want to ask a person to precisely draw the line to outline the boundary of Northern California and Southern California, it seems to be a mission of impossible. This is because both of these two places are vague. We can use fuzzy set or membership functions to model such vague places. However, to construct a reasonable membership function is difficult. The social media data, fortunately, provide us an efficient way to construct such membership function. Here, I will show you with the support of Flickr data, Twitter data, and Instagram data, and Wiki data. We collected such data and then calculate the kernel density surface. They can be viewed as a proxy to represent the membership functions to model the vagueness of places. Also, at the urban scale, we can also use a similar approach to construct the membership functions of different places inside a city. For example, in Beijing, Zhongguancun and Forbidden City and so on can be easily constructed with the support of social media data. Also, as we all know, hierarchical structure are important in human knowledge organization. If we want to if we want to build the hierarchies among different places, it is a challenging task. In this research, we introduce fuzzy form concept analysis to automatically build the tree-like structure of places. Sorry, may we pause for a while? There are phone call in. Sorry. Let's go on. Sorry. Now that we have the spatial extent of different places, we can enrich the semantics of such places from different perspectives. First, we can extract activities associated with different places. With the support of social media data, we extract the verbs and then count the frequency of different activities such as work and study and entertainment. These two figures show the activity density of work and study in Beijing, and the entertainment density also in Beijing. We can see, interestingly, we can see that in east part of Beijing, there are more entertainment activities. However, as a contrast, in the west part of Beijing, there are more work and study activities. This can be validated using another approach. We can also evaluate the sentiment from social media data. For example, we can measure the degree of happiness or sadness from social media data, and then we draw the hotspot of different feelings. In the left figure show the hotspot of happiness, and the right figure show the hotspot of negative emotions. We can clearly see the contrast between two parts. It seems that in East Beijing, the resident seems much happier, right? This is consistent with these findings, since in east part of Beijing there are more entertainment activities, right? And maybe work and study makes us unhappy or sad or depressive, right? Okay. Also, we can use text data to count the number of the activity volumes in different places. For example, in Shanghai, taxi plays an important role in intra-urban travels. The left figure shows the pick-up points and drop-off points in one day. There are no clear patterns. However, if we divided the study area into one square kilometer regions, the number of drop-offs and pick-ups in each hour are different, and we can draw temporal signature curves in different areas. For example, C is an airport of Shanghai, Hongqiao Airport. We can count the number of drop-offs denoted using a blue line, and the number of pickups denoted by red line. And we can see that in different areas, because their functions are different. For example, in this area, maybe a commercial area. In this area is a residential area. Their temporal signatures are also different. This implies us we can infer the land uses from the temporal signatures captures from different types of big data, such as mobile phone data, text data, and social media data. And this figure is clearly demonstrates such a pattern. In morning time, the difference of pickups and drop-offs shows one pattern. And in evening time, the pattern is reversed, right? For example, in morning time, this is the downtown area, there are more drop-offs. However, in residential area, there are more pickups. However, in evening time, in residential areas, there are more drop-offs, right? So we can use the such temporal patterns to infer the land use characteristics. Okay. Here I show you the framework of such idea. Inside a given city, there are different land use sectors, and the temporal rhythm associated with different areas are also different, and we can capture the temporal signatures using text data and mobile phone data and so on, and we can delineate the different functions, different areas with particular functions, right? And recently, the rapid development of development of artificial neural network help us to extract information from images, or this makes computers to understand the content of a given photo or image. Maybe many of you know that many companies have collected large volumes of street view data, such as Google and Tencent and Baidu. With the support of CNN or deep learning network, we can measure the human perceptions associated with a given image, and then we can assemble such scores at the street level, and then we can measure the human perceptions of different streets. For example, this is the safety score of Beijing streets, and this is the beautiful beauty scores of the street. Such scores makes us to understand the spatial structure inside of Beijing, and also help the urban planners to make more scientific the decisions, right? Also, we can infer the activity volumes from street view data with a deep learning framework. The precision is about 70%. This is rather high. It means that given a picture, we can roughly know the crowdedness of such area. However, besides such findings, we also find some outlier places. This mean from the street view data, there should be more activity. However, the actual data is relatively low, or the situation may be reversed. It means that the urban planners should pay more attention to such places. Okay. Besides sensing places, different types of big geo-data also help us to sense spatial interactions. Spatial interactions can be viewed as a second-order measures between a pair of spatial units. For example, the passengers from one city to another city, or the mobile phone call volumes between two areas can both be viewed as a proxy or a measure to spatial interactions. Spatial interaction has played an important role in human geographical studies. About 70 years ago, Professor Ullman has written a book entitled Geographical and Spatial Interaction, highlighting the importance of spatial interactions. In other words, from spatial interaction patterns, we can better understand the spatial interaction, the spatial structure of a given area, including a city, a region, a country, or a world. Here, I show you an example of spatial interaction. I have explained earlier. This is measured using taxi data. For a given pair of TZs, we can count the number of taxi trips, which can be viewed as a proxy to the spatial interaction stresses of these two TZs. And now that we have the spatial interaction volumes for any pair of TZs, we can perform a number of analyses for such interaction network. First, we can regionalize the study area based on the spatial interaction stresses. This means if a group of places or spatial units have relatively stronger spatial interactions, they should be grouped together. And following this idea, we can divide the study area into particular subregions, and these subregions help us to understand the intra-urban structure. This research was conducted using the taxi data of Beijing, and we can see there is a difference for weekdays taxi trips and weekend taxi trips. This means the human activity or movement patterns are slightly different for, on weekdays and weekends, right? From the structure, we can find that the structure is consistent with classical theory entitled central place theory. which it was firstly proposed maybe 100 years ago. This research is conducted using Shanghai data. We find a polycentric hierarchical structure. It's very similar to what is described by central place theory, right? Also, the temporal characteristics of spatial interaction can tell us the useful information of particular places. For example, we also use the text data and count the temporal variation inside one day. We can see there is a interesting pattern. During daytime, the interaction volume is very low. However, after 6 p.m., the interaction strength is increased rapidly. We plot such traffic units into the map, and we can see most spatial interactions are associated with famous bar street area, Sanlitun, and this findings tells us we can describe the place characteristics from both first order characteristics such as human activities, population density, and so on, and second order properties such as spatial interaction strengths and their temporal variations, right? And following this idea, we developed land use classification framework that integrate both first order properties and second order properties. This paper had been published, and the framework it was constructed based on EM, the expansion maximization framework, right? And here is another example of such idea. Maybe many of you know three famous cities of China: Beijing and Guangzhou and Shenzhen. The distance between Beijing and Guangzhou and Shenzhen are close, and also the population of Guangzhou and Shenzhen are also close. It means that the trips from Beijing to Guangzhou and Beijing to Shenzhen are also close, and this is the observed volume. Clearly, they are very close, right? And if we plot the residential location of the passengers to Guangzhou and to Shenzhen, we can see there exists a clear difference between them. You know, Guangzhou is the capital of Guangdong City. However, Shenzhen is a new city with many high-tech companies and financial companies. And Guangzhou plays a role of administrative functions, right? So it is interesting that we found the passenger to Guangzhou mainly distributed in government and military units and the other government-related places. However, regarding Shenzhen, the passengers are mainly distributed in universities, high-tech areas. So this tells us we can differentiate the urban functions based on intra-urban land use distributions with the support of spatial interaction data, right? As we all know, spatial interactions are governed by the effect of distance decay. With the support of different types of big geo-data, we can quantify the distance decay effect from text data, social media data, and so on. Here I list some findings of my group. We found that for intercity movement, the distance decay coefficient is about 1.0. However, for intra-city movement, the distance decay effect is a bit higher. It's roughly equal to 1.5. These two parameters can help us to make scientific urban planning, right? Also, the spatial interactions may follow the spatial interactions may exhibit some particular patterns. For example, clusters. We can extract useful or meaningful clusters from similarly messy floors. This figure shows the text strips in Shenzhen area, and there are no clearly patterns, right? However, if we conduct clustering analysis, we can find some floor clusters. These clusters can is useful for public transportation planning, right? So here we reach the concluding remarks. There are some takeaway notice for you. First is the social sensing concept. It means that we can infer geographical environmental characteristics from large volumes, individuals' human behavior patterns, and with the framework of social sensing, we can conduct studies to sense places and spatial interactions. They roughly correspond to first order measures and second order measures. These two measures both help us to understand our city. And regarding the tasks of geoscience, we should develop more useful tools to analyze various social sensing data. For example, the clustering analysis, spatial dependency analysis, and and the forecasting analysis, and so on. Although many big geodata has the merits in urban studies, they also encounter some quality issues. For example, the bias, the representativeness. We should fully aware of such issues. This will make the conclusions based on big geodata more convincing. That's all. Thanks for your attention.